Hello YouTube viewers, welcome to this video. I'm Venkat and this is just me, an open source channel. Right, in this video I'm gonna show you how you can set up a Kubernetes cluster using LXC containers. We've seen various ways to deploy Kubernetes cluster. I think I've done like 3 or 4 videos on how to set up the Kubernetes cluster for development or testing purpose. So if I go to YouTube, the first video I did was Kubernetes cluster using Kube. So in this video, I showed you how you can install and set up Kubernetes cluster on bare metal manually using a Kube package. So we understood the fundamentals and then we automated it. And on my second video, it's right here, Kubernetes cluster using Vagrant. So we used Vagrant to automatically provision the Kubernetes cluster on bare metal on virtual machines. So that's our second video. And then the third video was setting up Kubernetes cluster with micro-K8s. I did this on an Ubuntu machine using Snap Package Manager, Snap install micro-K8s. It's a lightweight option if you want to test it. And then I also did a video on Minikube. Basically, you have a virtual machine or you can use your host machine, and this will deploy a single node Kubernetes cluster. So to that series, I'm going to add another video, which I'm recording right now. And it is how to set up LXC container, how to set up the Kubernetes cluster using LXC containers. Again, it's going to be very lightweight. The idea behind this is the Linux containers are very lightweight, unlike virtual machines, which take huge amount of hypervisor resources. LXC containers operate on the host kernel, so there is no overhead of running multiple LXC containers. You can run many containers than the virtual machines. And also, if you want to, I'm not going to go deep into the LXC and LXD bit because I did a video on that as well. If you want to see that video, search for getting started with LXC containers. So the video down here, getting started with LXC containers. So that's the video I did where I introduced what LXC containers are, how to use LXD, LXC profiles, snapshots, and it's a bit lengthy video. It's like 48 minutes. So I would suggest you to go through that video before watching this one if you want to try along with me. Okay, so as usual, I've got notes for this demo. What I'm going to be doing is I'm going to set up a Kubernetes cluster using the LXC containers, and my environment is I've got an Arch Linux machine. It's not exactly Arch Linux, it's a Manjaro, which is Arch based. It's Dell XPS 9370 with 8 core, 16 gig RAM. I'm running kernel 4.19 Manjaro, but I wanted to show you how it works on Ubuntu because Ubuntu is more widely used, obviously, and Arch Linux, very few people use it. I personally like it; it's a bleeding edge. But anyway, I thought it would be useful to show how it works on Ubuntu because I've already got a Kubernetes cluster on my host machine, so I didn't want to break that environment. Right, on my host machine here, I'm going to create a virtual machine, Ubuntu 18.04 virtual machine, and I'm going to use 4 core and 10 gig of my host machine for this virtual machine. And inside that virtual machine, I'm going to create 2 containers, LXD containers, KMaster and KWorker1, each with 2 CPU and 2 gig of RAM. So I'm going to show you how we can do this. To provision the Ubuntu 18.04 machine, I'm going to use my vagrant file that will provision this virtual machine using VirtualBox provider. So that will be my setup for today's demo. Let's dive in. The first thing I'm going to do is I'm going to git clone my vagrant repository. The links will be in the description if you want. Cd to vagrant and then to vagrant files, cd to Ubuntu 18. I'm going to edit my vagrant file just to bump up the memory and CPU. Memory, let's give it 10 gig, 10240, and I'm going to give it 4 CPU. Okay, and then I'll do vagrant up. So I'm going to wait for this machine to come up. It's going to take 30 seconds or so. Right, the machine is up. If I do vagrant SSH, lsb release. Okay, so I'm on Ubuntu 18.04. I'm also going to log into this machine on my other pane. cd to vagrant files, Ubuntu 18, vagrant SSH. Okay, right. We've got the Ubuntu 18.04 virtual machine now. And let's initialize the LXT environment. Which LXC, which LXT? So by default, as is shown in the getting started with LXC containers, if you're using Ubuntu 18.04, LXC and LXT should already be installed. If not, just do sudo apt install LXT. That will install LXC client libraries and everything. But it's not started. Sudo systemctl status LXT. As you can see, it's enabled, but it's not running at the moment. But before that, we've got one more thing to do. So as you have noticed that I've used vagrant to provision this virtual machine, my user ID is vagrant. There is a group called LXT. So I'm going to add vagrant user to LXT. The reason I'm adding this is if you want to do any LXC command, you need to be using sudo or become root to do that. So if you want to use a non-root user, you need to add the user to the LXT group. Sudo gpassword -a vagrant and the group LXT. So if I do id vagrant, so vagrant is now a member of the LXT group. To take effect, new group LXT, or you can just log out and log back in. Let's do that. Control D, vagrant SSH. Let's do the same here as well. Vagrant SSH. Right, now we are ready to start the LXT service. Sudo systemctl start LXT. Sudo systemctl status. Okay, LXT service is running. Now we need to do a command to initialize the LXT environment, which is LXT init. Would you like to use LXT clustering? No. New storage pool, S. Name of the pool is default. The backend I'm going to use is dir. No. I'm going to use the default options for everything. If you have watched my previous video on getting started with LXT, I would have explained all these options. So as I've done on the previous video, I'm just going past all these options very quickly. Right, LXT init has been done. If I do LXC list, cool, we haven't got any containers yet. The first thing I'm going to do is I'm also going to git clone my Kubernetes repository. Git clone https github.com just me and open source Kubernetes. cd to Kubernetes, and there you will see LXT provisioning. cd to LXT provisioning. There you'll have a couple of files. I'll tell you what each file does. So now we are going to create a couple of virtual machines, a couple of containers. All these containers will be CentOS 7 containers. So if you look here, now we are in this stage. We have deployed the Ubuntu 18.04 machine. We've enabled the LXC service. And now we are going to create these two containers, kmaster and kworker. By the way, let's look at whether we've got the 4 core and 10 gig for the Ubuntu virtual machine. So on the virtual machine, we've got 10 gig of RAM and 4 core. That's what we wanted. So now we need to restrict each of these containers to use not more than 2 CPUs and 2 gig of RAM. If you use the default profile, it's going to allocate the entire 4 core and 10 gig RAM. All the available CPU and the RAM, the memory, will be available to each of the containers unless you restrict it. Okay, so LXC profile list. So that's the default profile. Let's take a look at it. LXC profile show default. So there is nothing specific about it. What we're going to do is we're just going to copy this profile to a new profile and then make some edits to that. LXC profile copy default to something called K8s. LXC profile list. So now we've got the second profile which we copied. If I do LXC profile show K8s, it's exactly the same because we copied it. So now let's try and edit this file, edit this profile. LXC profile edit K8s. Okay, and what I'm going to do is let's change the description. Default LXC profile to Kubernetes LXC profile. I'm going to leave the networking and the file system, everything same. But in order to run a Kubernetes cluster, any node, master node or worker node, using an LXC container, you need to set specific configurations. Otherwise, it will fail when it comes to Kubernetes cluster initialization. Because these are cluster nodes, they need to be able to create Docker containers and run containers within containers, because these machines, K-worker, K-master, and K-worker are all containers, and we need to create Docker containers within these containers. We need to set specific options in the profile. Okay, so cd to Kubernetes LXC provisioning and K8s profile config. So I've got some configurations that you need to add to this profile. Let's take a look what's in there. K8s profile config. Okay, let's better pipe that to less. The config that I'm interested in are these things. Okay, so limits.cpu, I'm going to limit the CPU that each of these containers to 2 CPU. You can't use more than 2 CPU. It's always a better practice to restrict it. Limits.memory, I'm going to allocate 2 gig of memory to each of the containers, LXT containers. I'm going to disable swap, and then I'm going to load these kernel modules, enable those kernel modules. And there are some options here, C group and mounting app armor profile and so on. And these two are again important, security.privileged. In the default profile, so this is the default profile, you won't see any config. And if you create a container, it is an unprivileged container, meaning it won't be able to do any elevated tasks. So our containers needs to be able to run containers within it, and it needs to modify certain file systems. So we need to make the container a privileged container. So security.privileged needs to be set to true, and security.nesting also needs to be set to true, which is security.nesting is only if you enable this, you can create containers within containers, right? I'm going to copy these, close it, and I'm going to paste it here. Okay, Control X, Y, that's done. LXC profile show K8s, and you can see our options are all good, looking good. Okay, so now it's the time to create the machine containers. I'm going to use CentOS 7 container for kmaster and kworker. Let's do that. LXC list. I haven't got anything at the moment. LXC launch images CentOS 7. So now we are going to create the kmaster container. So let's give it a name, kmaster. Minus minus profile. We don't want the default profile. We created a custom profile that sets the memory and CPU limit and other options. So we need to use that profile. Okay. So it's creating the kmaster. It's going to retrieve the image. This is the first time I'm running inside the virtual machine. So it's going to take a while to download the container image. I think it's about 200 meg or something. So I'm going to pause the video here and come back when it's been provisioned. Alright, the container is running now. If I do LXC list, you can see kmaster EDH0 and it has got an IP address. I should be able to ping it 10.18.70.69. Yeah, cool. LXC list. Cool. And let's also create the kworker1 container. LXC launch images CentOS 7. I'm just going to use the same command and change the name to kworker1. Right, kworker1 is also running at the moment. This time it took less than a couple of seconds because we're using the same image, same machine image, and we pulled the image when we started the kmaster, so it's using the same base image. So this time it took less than 2 seconds. LXC list, we've got kmaster and kworker. It's a plain vanilla machine image. We haven't done anything with it, and now it's time to provision the cluster onto these two containers. We can also log into these machines. LXC exec kmaster bash. Okay, so we are inside the container. If I do cat etc red hat release 7.6 LXC exec kworker1 bash etc red hat release. So both are CentOS 7.6 machines. Free minus m. Come on, free minus m. As you can see, it has got 2 gig of RAM, and this container also has 2 gig of RAM. nproc, so 2 CPUs. So we've got these containers, kmaster, kworker, 2 CPU, 2 gig RAM. It's all good. The only thing left is to set up the cluster. Okay. So now comes the next file, Bootstrap Cube.shell. Let me show that file, what it's going to do. Okay. Okay. It's a simple shell script. What I'm doing here is I'm installing Docker, Docker Community Edition version 18.06, and then I'm enabling the Docker service, starting the Docker service, adding a repository file for Kubernetes, and then install kubeadm, kubelet, kubectl, and then I'm enabling the kubelet service, and then installing configure SSH. I'm installing the SSH server if I want to log into these machines, but that doesn't matter because we can use the LXC exec command to get into those machines. I'm setting a root password in case if we want it. I'm installing additional packages, and then you can see here to be executed only on master nodes. So I'm having a check to see if we are running the script on a master machine or a worker node. So if you're following this video and if you want the script to work, you need to name your master machine kmaster or anything that has master in its name, because I'm doing the check here. You can do kmaster, kmaster node, kmaster1, whatever master. So it has to have master in its host name, otherwise this shell script won't create the cluster. Okay, so I'm initializing the Kubernetes cluster here. I'm deploying the flannel overlay network. I'm generating a cluster join command that will be used by the client. Okay, so now the following block will be used only if it's on a worker node. I'm doing a check again to see if the host name contains worker. So k worker node, k8 is worker, whatever you name it, but make sure you've got the name worker in your host name somewhere. So join node to the Kubernetes cluster. So I'm pulling the file that I created here, echo join command to /join cluster.shell, and I'm using SSH parse to log into kmaster and copy that file. That file contains the command required to join the cluster. And then I use the bash to execute that file, which executes the cluster join command. And that's it. Okay, so how do I execute this Bootstrap script on each of these containers? Okay, so cat bootstrap and pipe that to LXC exec kmaster bash. That's it. Right. It's going to do a series of steps as I explained in the shell script. It's going to take a little while, maybe 4 to 5 minutes. So I'm going to pause the video and come back when it's done. All right, the bootstrap command completed successfully, and you can see what it did. So it installed the Docker container engine, it enabled and started the Docker service, added the Kubernetes yum repository configuration file, installed kubeadm, kubelet, and kubectl. It enabled and started the kubelet service. It configured SSH, it set a root password, it installed some additional packages, and it did initialize the Kubernetes cluster, and it copied the kubeadm config to root user so that the root user can run kubectl commands. It deployed the flannel overlay network, and it generated the command to join the cluster to the file, which the worker nodes can download this file and then run this file. Okay, so as my machine is named kmaster, the script is clever enough to run these bit of commands just on the master machine. So if I run the same script on the K worker, you won't see the cluster initialization. Instead, you will see the cluster join command getting run. Okay, let's set up the K worker node now. Cat bootstrap pipe that to LXC exec K worker 1 bash. Right. I'm gonna pause the video here and come back when it's ready. Alright, the bootstrap command completed successfully on the worker node as well. And you can see the difference here. So it didn't initialize the Kubernetes cluster, but it did this task, join node to the Kubernetes cluster. So our Kubernetes cluster should be up and running in the LXC containers. Let's verify that. LXC list, if I do that, you can see the kmaster. So that's the actual Ethernet interface, and that's the interface that it created for the flannel overlay network. And you can see the flannel overlay network on the K worker 2 as well, and the ETH0 network interface. So kmaster, K worker 1 both are running. Let's log into kmaster. LXC exec kmaster bash. Right, kubectl cluster info. Cool, cluster is running. Kubectl version --short. Right, as of recording this video in March 2019, the version is 1.13.4, server version is 1.13.4. kubectl get nodes. Cool, so we've got 2 nodes. Both are in the ready status, and you can see, so this is the master, up for 5 minutes and up for less than a couple of minutes. Cool. kubectl get pods. We haven't got anything yet. kubectl get pods --all namespaces. All right, so you got the core DNS service, etcd, the API server, the controller manager, and the flannel as a daemon set that runs on both kmaster and kworker, kube proxy running on both kmaster and kworker, and the kube scheduler. So our Kubernetes cluster is healthy. kubectl get component status. Cool. Everything looks okay. So now let's try and start a deployment. kubectl run nginx -- image nginx. Okay, the deployment has been created. kubectl get all -o white, and you can see the container is getting created. And there's the deployment for nginx and the replica set. Let's see, kubectl describe deploy nginx. Okay, replica set scaled up. kubectl describe pod. I haven't got the bash completion enabled. That's not a problem. kubectl get all. Right, our nginx service, nginx pod is running. If you want, you can scale it. kubectl scale deploy -- replicas 2. Scale deploy, I didn't specify the deployment name. It's scaled kubectl get all -o white. Since we've got one worker node, all the pods are getting deployed on this one, and it won't get deployed on the kmaster because it has got a taint associated with it that prevents the pods from getting deployed onto the kmaster. Right, all of them are running. Let's delete it. kubectl delete deploy nginx. Deleted. Okay, the pods are getting terminated. I think that's all I wanted to show you in this video. I don't want to drag the video, but the essence of the video is you can run your Kubernetes cluster in machine containers, in LXC containers, 2 core, 2 gig of RAM. That's all you want. Right. If you want to follow along this video, I would highly recommend watch my previous video on getting started with LXT containers, where I've explained every bit of how LXC and LXT works, profiling, snapshotting, copying, and how to SSH into the how to get a shell into the machine, and so on. Right. If something is not working for you, or if you're using a different distribution and you need some help, please leave me a comment. And the more the questions you ask me, the more I can learn myself, because whatever I'm showing you might not be the right thing. Whatever I know, I'm just explaining things to the viewers. If you find something wrong with my demonstration, please let me know. I also need to learn more from you guys if you've got some experience on these topics. Right, and thank you so much for your time watching this video. If you liked it, please share it with your friends, and don't forget to subscribe. I've got a few more videos in the Kubernetes series waiting to be released. Cool, I'll see you in my next video. Bye bye.